Welcome back. We do mathematics and we focus on trigonometry, where we work with identities and the derivations thereof, including the double angle identities and how to derive them. At this stage, the two main identities familiar to us is sine of x over cos of x is equal to tan of x. But this can also be written as where I isolate sine of x, where I want sine to be the subject of the formula. I can write it as sine of x is equal to tan of x multiplied by cos of x, meaning I multiply by cos of x on both sides. Cos of x will cancel out cos of x, and I will be left with tan x cos x. Then I have, if I want to go from here, and I want to make cos the subject of the formula, all I need to do now is divide by tan here, divide by tan. Tan will cancel out tan, I'll be left with cos of x is equal to sine of x divided by tan of x. The identity sine square x plus cos square x is equal to 1. When I work with this identity, I notice that I can actually write this as, if I want to isolate sine square x, it will be equal to 1 minus cos square x. I can take this even one step further and say, okay, so sine of x is equal to plus or minus the square root of 1 minus cos square x. But I'm not going to focus on that one yet. The main one I want to focus on is 1 minus cos of x squared. So, if I want to make cos of x squared the subject of the formula, all I need to do now is subtract sine on the left hand side, subtract sine on the right hand side, and I've got cos square x is equal to 1 minus sine square x. This derivation from the original identity is commonly used from one way to the other, or to rewrite from one version to another. When I work with my double angle identities, cos of 2x and sine of 2x, they can even expand this to sine of 3x. They can expand this to cos of 4x, any which way they like. So let's look at ways how we can remember how the double angle identity can be expanded. Let's start with sine 2x. Sine 2x becomes 2 sine x multiplied by cos of x. Relatively easy to remember if I practice enough with it. If I go to cos 2x, 2x means cos of x plus x. So the cos double angle identity expands to cos square x minus sine square x, and we will show in the next slide how that happens. Then, if I substitute this sine square x with 1 minus cos square x, which I had in the previous identity, remember, sine square x plus cos square x is equal to 1. So that means sine square x is 1 minus cos square x. So minus cos square x will give me a positive cos square x, so that is 2 cos square x minus 1. And if I substitute this cos square x with 1 minus sine square x, I will have 2 minus sine square x's, so it will be 1 minus 2 sine square x. We will shortly look at how this expands and how we get to these results that we work with. If our double angles are two different angles, cos of alpha plus beta, or sine of alpha plus beta, then we can derive from them that our new ratio will now be sine, cos, sine. In sine, the sign stays the sign, meaning a positive stays a positive and a negative stays a negative. So let's look at the double angle of different angles with sine. The rhyme that I teach is sine, cos, cos, sine. In sine, the sine stays the sine. Even for the negative angle, it will still be sine, cos, cos, sine. In sine, the sine stays the sine. So negative stays a negative, positive stays a positive. First angle that's substituted is alpha, then beta, then again alpha, then beta. Do not swap them around. It must be alpha, beta, according to the angles that is listed in the same order as it's here. Right? So that will apply for sine alpha minus beta will also be sine cos cos sine. The sine that is negative stays the sine, so it stays negative. So then my angles that are substituted is then, because it's alpha minus beta, my angles will be substituted alpha, beta, alpha, beta. When I work with cos, the rhyme is slightly different. The rhyme for cos is cos, cos, sine, sine. In cos, the sign changes. You can see a positive has become a negative. So, for cos, the rhyme is cos, cos, sine, sine. In cos, the sign changes. And sign that I talk about here is S-I-G-N. Plus or minus will interchange. Likewise, with cos negative, alpha minus beta will be cos, cos, sine, sine. The negative changes to a positive. So, my angles are still substituted in the same order of appearance, alpha minus beta. So I will first have cos alpha, cos beta, sine alpha, sine beta, and the sign changes from negative to positive. Get to the discussion that you wanted to see. When the angle is the same, the rhyme still applies for sine, sine, cos, cos, sine. The angle that is substituted is now alpha plus alpha, so it's alpha, 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 alpha. And the sign stays plus. So I have sine alpha cos alpha plus cos alpha sine alpha, and cos alpha sine alpha can be written as sine alpha cos alpha, which means I have 2 times sine alpha cos alpha. When I look at the cos of alpha plus alpha, I have cos, cos, sine, sine, the sign changes. So cos alpha times cos alpha is cos square alpha. Sine alpha times sine alpha is sine square alpha. So the sign changes from plus to minus. So I have cos square alpha minus sine square alpha, which is one of the derivations of cos of 2 alpha. We saw in the previous calculation that cos 2 alpha can be written as cos square alpha minus sine square alpha. Now I just want to take a moment and say the first identity that we learned of was sine square alpha plus cos square alpha is equal to 1. So from here, I can substitute in the place of sine square x. What is sine square x? 1 minus cos square x. So I can substitute sine square alpha with 1 minus cos square alpha. Now that I've substituted, a minus times a plus is a minus times a minus is a plus. So I'm sitting with cos square alpha plus cos square alpha. So that gives me 2 cos square alpha minus 1. So now we've seen that cos 2 alpha was written as cos square alpha minus sine square alpha. So if we now substitute cos square alpha with 1 minus sine square alpha, according to our very first 2 identities, then we will have 1 minus sine square alpha minus sine square alpha. So that means we have minus 2 sine square alpha. So 1 minus 2 sine square alpha is equal to cos 2 alpha. And that shows us where these three derivations, including that one, comes from in the double angle identities. Thank you for watching. We will see you in the next video. If you liked it, tell your friends. If you did not like it but loved it, please share your experience with us. Have a great day further.